G'day folks, my name's Andrew Reid. I'm from Haald Engineering, a mechanical engineer there, and I'm here to just have a brief chat to talk about our experiences with Pro Engineer slash Creo and also ANSYS. Let's just start off with a brief introduction to Haald Engineering. We'll have the obligatory safety share, a little bit different this one, and I'm going to steal 5 minutes of your life for this. SolidWorks, our journey from SolidWorks off to Pro Engineer and then on to Creo. And just a little bit about ANSYS. I might warn you that I'm not an expert in any of these programs. I sort of amateur level of ANSYS and very little of Pro Engineer, but pushing it for quite some time. So Haald Engineering, well, we're a civil structural mechanical piping consultancy. We do things all the way from tiny little triaxial stress freaks all the way through to full-blown materials, handling plants, coal, gold, whatever, all around the world, not just here in Australia. If you can think of anything that's got anything mechanical structural in it, then we've had a little bit to do with that sort of stuff. All different types of software, the FEA, half a dozen different packages on that. Primarily ANSYS, but obviously on the structural side of it, we use software that for code compliance stuff, which not necessarily ANSYS, but certainly on any of the mechanical stuff, it's ANSYS. And we still use SolidWorks on the smaller stuff that we do. Any of the bigger stuff, then it's all combination of Pro Engineer and Creo. Some of the stuff we've done, well, I said we do smaller to bigger. Well, there's a complete, well, that's the wash plant as well as the product coal side of a full coal plant. All of that was done in Pro Engineer. It's a thing at night time. It's high level of detailing, and this was a screenhouse upgrade up at Auckland done quite some time ago. Obviously, with the 3D modelling stuff, this is very, very beneficial. These guys want I forget what it was, some crazy 2-3 day shutdown or something to shut the plant, rip out the old stuff and roll in the new stuff. So they already had the side of the building cut out, which for some reason or other you're not seeing what I'm seeing here. Anyway, they had the corner of the building cut out like that, took the columns off. So as soon as they shut it down, they just ripped it out. The new module had everything hooked up, wiring, the whole lot, wheel it in on the hydraulic modules, put it in place, hook it up, and away they go again. So things have to be right. So getting good, accurate 3D models is very important. I said we'd have a safety share. So currently, in the workplaces, we still have around 180 fatalities every year. Not good. There's reasonable data that would suggest that at least some of those fatalities are as a result of self-inflicted self-harm, which is not a good thing. There's billions spent on workplace health and safety, but only hundreds of millions on suicide. We have around over 3,000 deaths by suicide every year. So I'm just going to give you this. This is where I steal 5 minutes of your life, because it's got nothing to do with Pro Engineer or ANSYS. And a lot of safety shares start off with talk about the guy being on site with sunglasses instead of safety glasses. I'd suggest this is a little more relevant than that. So bear with me. It's you won't get bored. If I can just get this thing cranked up.
My name is Dylan, and this is my brother Lawson. We're riding our bikes around the world, fundraising for leading-edge mental health research at QIMR Berghofer.
We launched QIMR Berghofer Medical Research Institute in March 2015 and will return there on World Mental Health Day, 10th of October this year. The ride will total nearly 100,000 kilometres over 2.5 years. Our dream is to help medical professionals more accurately diagnose and treat patients suffering from mental illness. motivated because our lives were shattered by the loss of our brilliant sister, Heidi, to major depressive disorder. Heidi was all brains and compassion, with a bright future in the field of epidemiology and population health. Tragically, she had an episode when she returned from work with the Malaria Consortium in South Sudan. She was home to bowl over her PhD, but in the end, she scrambled up Mount Tibrogargan with full boxes of antidepressants and antipsychotics. Heidi was 27 years old when she went over the edge. I can't really explain the train of thought that led to this ride, but ultimately our family hoped to get the broader community's attention and highlight the fundamental issue in mental health, which is we can't medicate and treat people accurately because we can't diagnose accurately. We've only just started scratching the surface in understanding how the brain functions and how its dysfunction leads to disorders. QIMR Berghoff are world renowned for their work in genetics, population health, and the clinical aspects of mood disorders. They have combined those strengths with new techniques in neurosciences, and now they're on the brink of creating world-first diagnostic tests for mental health conditions.
Thanks for watching and indulging. Just as a follow-up to that, on the news just recently they announced that they've actually made breakthroughs and have identified a number of genes that are responsible for mental health, and now the next step is to try and isolate which particular genes cause which particular illness, and then target medicines for those particular genes. So it is progressing. It's very promising actually, and QIMR do a fantastic job on this sort of stuff. So let's get on to what we're actually here about. Sorry for that. Thank you for indulging us there. So why Creo ANSYS? So why did we go to Creo ANSYS? Well, here was a project that we did. This was up at Auckland, and these were conveyor galleries. These things were all what they call PAMs, pre-assembled modules. So these things were made in Thailand, fully assembled, kitted out, all the conveyors inside, everything, piping, the whole lot. They bring them to site, they pick them up, you can see the cranes there, just pick them up and dump them down onto the pedestals. So this is because of the site costs in Australia. This particular project we did in SolidWorks, and we started to have problems towards the end of this project, and all of our stuff is done as top-down design. So we create skeletons and then we build off those skeletons so that if you want to make changes, you adjust your skeletons and then all your model updates. It's not an efficient way if you're doing tiny little things necessarily, but on stuff like this, it's the only way to do it. So it became obvious to us that we're in strife. We had a look around at a number of packages. There was a level of arrogance from the bigger guys. We had a chat to Leap. They came in and had a yarn. And one of the first lines was, well, look, one of the first things you need to get over with Pro Engineer is this concept of skeletons. And I think that first sentence and the deal was done. You didn't need to show us anything more. I just looked at the principal modeler and we said, yep, this is what we're chasing. And it can handle big models. It's got some serious grunt. I'll just have a quick look down into one of these guys. So there's a fair level of detail in this, and not necessarily what we would do. There's a whole heap of safety and fire stuff in this that was they wanted to see in there, to the point that these guys were shoving spray nozzles around by 20 millimetres in this thing just to satisfy the insurance guys from Factory Mutual. As I said, reasonably large. We made the switch out of this into Pro Engineer, and the guys from SolidWorks were a little put out that we hadn't persevered with them, because as far as they were concerned, they could do large assemblies. In fact, afterwards, one of the guys from the States came out, and they came in and the local rep brought the guy in for a yarn, and we took him out to the drafting room and showed him some of that model live, and because he kept saying, "Oh, we can do large assemblies, you know, it's no problem." And he went out and had a look, and he was quiet. And I thought, well, we've obviously missed the mark here. And we went back into my office, and the local rep asked him what he thought, and he said, "Well, goddamn," he said, "we do large assemblies, we just don't do massive." So this was another one that we'd done in SolidWorks. It was taking us a day and a half to get drawings out of this when we were doing section views through it. It was just crazy. This one was done in Pro Engineer. This is two of those modules together. All of this was a learning experience, and frankly, the time it took to get the drawings out of this, we were wondering if we made the right decision. Pro Engineer still has an Achilles heel from our perspective on these larger projects, and that is the drawing modules. We have a way around it. This is the first of the bulk materials handling one. I'm sorry I haven't buried down deep into the conveyors or galleries or anything. There were no galleries in this one. This is actually a tunnel, and these are coal valves. And you can see from that bottom image that the above ground stuff is just as long as a lot longer actually than the other one. One of the things the guys typically ask, particularly from the SolidWorks world, when you tell them you're struggling with a model, well, how many parts have you got in your assembly? As soon as they ask that question, for me it's over. I can kill SolidWorks with one part and one feature. It's a crazy, crazy notion that you can identify the complexity of a model or the overheads required just by the number of parts in it. Some of these models are gigs in size. So that's down in the tunnel. One is the model itself, and that's the real thing. It was a big deal for us with these, having the client in. We do things called Rambos. For those of you who don't know what Rambo is, it's a design tool where you look at the reliability, accessibility, maintainability, buildability, and operability of your plant. All those things you need to look at. So you get the maintenance superintendent, he can't look at a drawing and get his head around what's going on. I tell you what, you put him in a 3D model and get him up into one of these coal valves so he can poke his head up and have a look at where his drive motors are on that thing. You've got the guy. There's no more feedback after that. He'll get exactly what he wants to be able to get into the line his chute and pull his motors out. And end of story. It's great. Syntec Resources, this was the first big one. If the oil can conveyors were massive, then this must be Gagooyan. Well, again, I've got this issue here. I'm going to have to pop out of here, and so we start over here. This is what they call the ROM, run-of-mine material. It comes down here into a hopper, down through a crusher, up through the conveyors in it. So if we just zoom in, you'll see there is a bit of detail on this. It goes all the way down into, yes, there are even bolts and nuts and stuff in there. So we do, on a level like this, we do what we call a detailed engineering. We don't do standard connections on this sort of stuff. We have a set of standard drawings, and those standard drawings, so this particular, at this level, we didn't go through the shop drawings. We certainly did shop drawings. Not at this level, we don't put that much detail in. But there's enough information in here for somebody to be able to create the drawing. So we go down in here through the crushing station. This is a wet process, all the way down here, in through the wash plant. You can see in here, as you keep going in, there's more and more detail the deeper you want to go into this thing. Handrails and bolts and nuts and handrails and that type of stuff. All the way up then to our stockpile side. So we have a reject side, we have a product stockpile side. And then all the way out here to our train loadout. I don't know why this guy's, get that off. So, and again, high levels of detail all the way into this guy. So, and yes, all the standard stuff on this. So, certainly quite a significant model, and the beauty of this one, and so the structural engineer working on this was very dismissive of 3D modelling and thought it was slow and a waste of time. Guys who are not used to it, they're used to getting drawings as the project develops. You don't get drawings out of this until you get very advanced. And the guys thought this was a significant amount of money to pay for something that was just basically eye candy. And the client was a little bit like that as well. But during the process of this, there was a change made to the balloon. So the balloon is this rail loop here. They go around a big balloon, you've probably seen that. And so the rail loadout bin had to change, it had to swing around. All the drawings were advanced at this stage. It meant there was stuff back at this level that had to change as well, and the guys were just beside themselves. How much was this going to cost? This was going to be months out of their schedule to fix all of this up to allow this to happen, as would be the convention in a normal AutoCAD plant. This was at, I don't know, 11 o'clock one morning, and by that afternoon, the whole thing had been rectified. Again, everything's sitting on skeletons. All this upper level stuff is sitting on skeletons. Change an angle, swing something around, modify a few dimensions. All of the rest of it's hanging down off this top level and just updates all the way back down to your drawings. So at that stage, all criticisms of the eye candy stopped, and it was considered then to be this wonderful tool that somehow had been developed overnight. Now, just for those of you who might have been critical of me using an Autodesk product, here is a typical result at the end of an Autodesk product. It'll sit here now and hang, so there's a negative aspect. Close the program. Okay, right.
And just a quick question for you. When you did that and you had to update the design, can you generate a list of the parts within your massive assembly that have actually changed, so you know what to look at and what you can ignore?
So we didn't have the windshield or anything like that on there, but at this stage we don't have published drawings. If we did have published drawings, we would be able to pick up. The guys know what's changing and what's not done. So I gather I'm out of time already. I'll just have a quick flick. This was one where it was an oh dear, oh my, a customer who had a problem. They were bringing in packages from all over the place, different packages, even stuff out of FEA that they needed to put together, and it wasn't happening. The guy stuck this together, and it's only little things he's picking up, like the discharge out of silos going straight down through conveyors into the concrete below, stuff like that. It all ended up getting built quite okay. This is a project in Africa, and this one we produce IFC drawings for that we can get out to Tekla, because effectively the fabricator would produce the workshop drawings for nothing. We found it difficult to compete with that. They sent us back the Tekla models, and then we could calibrate those against what we had in our model. We have this was now where we're starting to switch on to Creo. This was still Pro Engineer, but you can see this is brownfields, very, very dirty, running piping through here. This project went in without any clashes, so the whole by being able to get scan data and also existing models, this was very successful. This same site, we're doing a project at the moment in Creo where we're taking in massive scan data sets into Creo, and the excitement for us now, of course, is with Creo going on to augmented reality with this stuff. So, but then being able to walk around on site and just check what's happening with your piping really on site relative to the data that you've got, it's a big bonus. So, a bit of FEA, I won't go into the videos or anything like that. Explicit analysis with ANSYS on these. I put this one in because this one showed, this was the first model we used with space frame. Reduction in modelling time for us. The modelling is one of the more significant time consumers in our FEA. And this one went from 5 days down to 1 day to set it up to where we had a successful modal analysis coming out of it. You need imagination as well as all of your other great technical skills if you want to be good on design. I had the benefit of being able to go to a nuclear conference in Switzerland, and then down to see the Atlas detector and the Large Hadron Collider. well, which is all very high-end type stuff. And on the way home, ducked across to, it was going across to South Sudan, went into Ethiopia, where I went out to an orphanage, and these guys, their problem was that they had wheels in their grain. It was going to cost them 250 grand to build silos to get rid of the wheels out of the grain. I had a look at what they had, and I said, I can fix it for you for nothing. Grabbed a candle from the corner of the room, got a plate, put it down in their barrel of flour, put the candle on the plate, lit the candle, and put the lid on. And I said, well, what's that going to do? And I said, well, what happens is the candle will burn until all the oxygen is gone, at which point it will go out, and then there'll be no oxygen, and then you'll have no wheels. So there you go, there was a solution for nothing, made no money for us, and that's where imagination triumphs and experience triumphs over the rest. So as Einstein said, logic will get you from A to B, imagination will take you everywhere. So thank you very much.